So far in our quadratic unit, we have worked on solving quadratics by factoring, solving quadratics by using the rocks to find its solution at the x-intercept, and today we're going to solve quadratics by using the quadratic formula. This is like a classic, awesome algebra lesson for today. Before we can really get into the quadratic formula, we do need to simplify some square roots. Now this is a pretty easy process here. What you're going to do is you're going to break apart the number that's underneath the square root into its prime factorization. Then you're going to look at the end of all of the branches there, and you're going to circle any pairs of numbers that you see. So if a pair has a partner, a couple, you're going to circle those two numbers. And if there are any single numbers at the end of branches that don't have any partner, you're going to underline them. Now when I do this, I usually circle and then underline twice just so I see it. Okay, let's go ahead and break apart 96. If we break 96 into its prime factorization, we just start breaking down the numbers. Now this is not a t-chart, this is a straight up prime factorization, like a tree. Now 96 is divisible by 2, so that's 2 and 48. You can divide 48 by 2, and it's 2 and 24. 24 is divisible by 8, 8 and 3. And then 8 can be broken down into 2 and 4, and then 4 can be broken down to 2 and 2. So I've gotten them all the way down to its prime factorization for all of these numbers. We're going to circle the pairs. So here's a pair of 2's. Here's a pair of 2's. And then there's no more pairs because the only things I have left are a 3 and a 2 at the ends of the branches. Remember, ends of the branches. Now once you have your singles and your pairs, you're going to put them back together in a square root. So your final answer will still have a square root in it most likely. All of your single numbers, your singles, are going to go back together underneath the square root, and all of your couples get to pop out one time in front. Now if you have multiple singles and multiple couples like we will in this example, we're just going to multiply them together. So for square root of 96, we'd have a couple of 2's, that's this guy. We'd have another couple of 2's. We'd have a single 2 and a single 3. Now we're not going to leave it like that. We are just going to simplify this down and multiply. 2 times 2 is 4 and 2 times 3 is 6. So we have 4 square root of 6. Now that is the simplified version of this square root. And in your head you might be thinking, Ms. Quigley, there's no way that that's simpler considering it looks way more complicated. But in fact it is simpler even though it's the exact same. It's an equivalent expression though it's simplified because the numbers are smaller. Okay, let me prove that to you really quick. So here is me typing the square root of 96 into Desmos. Now to get a square root, you type SqRT, square root. Square root of 96 evaluates to 9.97979589. Yeah, you see it. It's called an irrational number. It just keeps going for forever. But if I also type in 4 SqRT of 6, it's the same exact number. So in fact, we've written an equivalent number, an equivalent expression. It's just simplified because the numbers are smaller and easier to hang out with. Great. Okay, so we have an equivalent simplified expression there. Now we need those square roots to be simplified because when we use the quadratic formula, we actually have a ginormous square root to take care of. Now this formula is on your formula chart, but it is the most important formula that most people remember from algebra class, besides y equals mx plus b. And how they remember it is that we sing it in song. So let me clear my throat and get my singing voice ready. You can say or sing the quadratic formula to the tune of Pop Goes the Weasel. Okay, here we go. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I expected you're clapping for me. Thank you for that performance. Now this it's a complicated formula, right? But it's on our formula chart. It's easily Googleable. You say, what's the quadratic formula? You can find it. It is something we need to have memorized, but we can look it up really quickly. How to use it, though, is really important. It's going to give us the two values for x that are my solutions. This is called plus or minus because it literally is a plus and then you do it again and it's a minus. So it's actually two separate equations simplified into one because we're saying plus and then minus. So we're still getting two solutions. To use this formula, we do need the quadratic equation written in standard form, which means it says equals 0 or f of x equals or y equals. And this one does. So very easily we can identify A, B, and C. Now we're just going to be plugging in A, B, and C to where they go in that formula. It is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And now I just got to simplify all of this. Okay, don't write this next part down. I just want to show you why we are learning how to simplify radicals, simplify square roots. And then I will show you a different way that I actually want you to solve these quadratics. So put your pencils down and just watch for a second. If you find this interesting, we'll talk later. So we have x equals the negative b plus or minus the square root of b squared minus 4ac all over 2a. Now that's a lot, so I'm going to start simplifying this using math rules. Minus a minus is a plus, so minus negative 2 is plus 2. Then we have the square root of b squared. Well, negative 2 squared, that's 4, minus 4 times a times c. That's actually 4 times 3 times negative 7 is negative 84. So if I subtract a negative 84, it's just like adding 84. All over 2a, 2 times 3 is 6. I'm going to keep reducing this down. 4 plus 84 is 88. And then, well, I just learned how to simplify square roots. So 88, if I break that down, that's 8 and 11. And 8 is 4 and 2, and 4 is 2 and 2. So I have a pair, and I have the singles. So this really means that I have x equals 2 plus or minus the pair, and 2 times 11, that's 22. Divide by 6, and then, oh, well, I can reduce those fractions. This is actually 1 plus or minus square root of 22 over 3. And then I can break these two things apart into the plus and the minus. So I have x equal 1 plus square root of 22 over 3 and 1 minus square root of 22 over 3. And like, yeah, I probably just blew your mind. That's fine. So those are my solutions, but like that doesn't really mean anything to most of y'all. Nor do I think you want to go through this process of simplifying this step by step each time. So what we can do is we can use Desmos to plug in A, B, and C into this formula and let Desmos do the work to find us an evaluated number, like a messy decimal or something. Okay, let me show you. So here comes the Desmos. We're going to type in the entire formula. Now, Desmos doesn't have a plus or minus button, so I'm going to just pick plus. So negative b, but I'm going to type b, plus the square root, so SqRT, of, again, the letter b squared, minus 4, and then the letters AC, all over 2a. Like just straight up the equation. Now, test mode will not pop up that option to add a slider, so we're going to type in a equals, b equals, and c equals so that we can plug in numbers. But remember, I've just done plus, but you can duplicate, the little page means copy, the formula and change it to a minus. So there, I have both the plus and the minus version of the quadratic formula. There. We'll plug in the 3 for A, the negative 2 for B, and the negative 7 for C. That's what we had on our paper. And notice that Desmos immediately gives me a good number that I'm going to have to round. Okay, I'm going to have to round that number for the solution. This quadratic would have a solution. It would cross the x-axis at 1.89 and negative 1.23. And this is exactly what we found when I did it on the paper. 1 plus the square root of 22 divided by 3. Yeah, that's the number we got when we used the quadratic formula with the plus. And then if I do 1 minus square root of 22 divided by 3, I'm going to get negative 1.23. This is exactly what I got when I did the quadratic formula. without having to do all that simplifying. So you can do both of those. I'm going to suggest that we use the Desmos, the technology, to allow us to compute these numbers pretty quick. They're not always going to be ugly like this, but when they are, we're going to round to the nearest hundredths place, which is 2 decimals. That's going to be pretty consistent throughout class for us. So let's round those numbers to the nearest hundredths. If you remember what they were, even though I just took it off the screen, we had 1.897, which rounds to 1.90. And we had negative 1.230, which rounds to negative 1.23. So again, we're rounding to the nearest hundredths for this class. That's 2 decimal places. Cool, let's go inside these notes and let's practice. We're going to have one more square root to simplify by ourselves. So let's take a second and figure out how we can break apart 147. It's not even, so it can't be divisible by 2, but if we try to divide it by 3, it's actually divisible by 3 and 49. And hopefully you recognize 49 as being divisible by 7 and 7. So I circle the what? Circle the pairs. And what do I do to the singles? Yeah, I underline them. Which one goes outside, the pairs or the singles? Yeah, the pair will go outside and the single will go inside. So 7 square root of 3 is equivalent to the square root of 147. If I were to calculate both of those in a calculator and just get their decimal answer, they would be exactly the same. They would be equivalent. So here are some tips for when we're solving using the quadratic formula, which we will be doing for the rest of the day. Not by hand, but using technology. So we're going to want to write the equation in standard form. Okay, some of you can see an equation without it being written in standard form, but if you don't have it in standard form, which again means that it says equals 0, or y equals, or f of x equals, then you probably will pick A, B, and C wrong. Because we have to make sure that we get the correct A, B, and C values for that quadratic. We are going to have to type the equation in. Now remember, it's on your formula chart, so you can just find it on that formula chart and type it into the formula line on Desmos. You'll duplicate it and change the plus to a minus so we get both. Then we're going to add A equals, B equals, and C equals on Desmos to give us the values. So for this one, we have standard form, so you have A, B, and C. Those are the numbers that we're going to use in Desmos and with my quadratic formula to be able to solve and find the solutions. So here we go. I left it in there just for time's sake, but you would have to type it in, and then type A equals 2, B equals -5, and C equals -18. And then Desmos will give you the solutions. And like I said, not all of them will be super ugly. In fact, this is 4.5 and -2. Those are pretty nice solutions. So we know that the solutions are x equal to 4.5 and x equal to -2. Those are the solutions just like we found with factoring, just like we found by graphing. But we use the quadratic equation. Great, awesome. Let's look at number 2. Is number 2 currently in standard form? No, it says equal 1, and that's going to be a problem because we need it to say equal 0, but no big deal. We know how to do that. We just use the inverse operation. So we're going to add 1 to the other side. It won't combine with anything, but I will then have w squared minus 4w plus 1 equal to 0. That's good. I need the equal 0. And now I have A, I have B, and I have C. So without having to factor, without having to graph, without having to do any of the other methods that we learned to solve quadratics, we can grab a Desmos and type in these values for A, B, and C, and let Desmos do the calculating for me. We type in 1, -4, and 1. Now, if we're writing this one down, again, remember we have to round, so we're going to take these numbers and we're going to approximately round them. Our solutions would be x is approximately, so wavy equal sign, which means I rounded this number, 3.73, and x is approximately 0.27. Remember, we round that up. 5 or more, raise the score. 4 or less, let it rest. Now, this is a harder question, so don't just click the answer that you think just yet. Think about this. Is number 3 exactly in standard form? No, yeah, standard form is A, B, C order, right? This one is actually written in A, C, B order, which is totally a trick that we could throw at you to make sure you're paying attention. Standard form is just going to be the rearranged version of this where the B value, the thing with the X term, is in the middle and the constant is at the end. No, I didn't have to move anything around, but if I didn't notice that A is 1, B is 34, and C is 289, I'd get a completely different solution here. So why don't you pause the video right now, toss this into Desmos, and let me know what the solutions are. So if we change these numbers to 1 and 34 and 289 for A, B, and C, something cool is going to happen. Yeah, you have negative 17 for both the plus and the minus version. That's totally okay. This has one solution called a repeated root since it repeats. Okay, so we know that the solution here is exactly negative 17 and that this is a repeated root. If we were to graph this quadratic, it would only touch the x-axis. It wouldn't like go through it and come back. It would just touch it at negative 17. Okay, repeated root. You don't really need to know that part, but it's good to know. It's called a repeated root. Is number 4 written in standard form? Yeah, no, definitely not. And the term that's on the opposite side, should it go here? No, it's a B term. It should actually go in the middle. So if we use inverse operations, we're going to be subtracting on both sides. So we'll end up with 2x squared minus 32x plus 178 equal to 0, which is good. We need the equal 0. And now we have A, we have B, we have C, and we're going to pull out our handy dandy quadratic equation, sing our little song to ourselves, and solve this. So here it comes. We change the numbers of A, B, and C to 2, negative 32, and 178. Bloom, bloom, bloom. And whoa, it says undefined. Now, this is really cool because if we just graphed this quadratic just to see what that meant, and see what it looked like, what do you guys know about this? Is that quadratic have any x-intercepts or any solutions? No, it is an undefined solution because there are no solutions. This doesn't cross the x-axis at all. So it has no solution because it has no solution. So if you get undefined, remember that means no real solutions. That's the phrase that we're going to use when the graph doesn't cross the x-axis or touch the x-axis. No real solution. The real part's important because it's undefined right now because you guys haven't learned about what are called imaginary numbers, but you will in Algebra 2, and then you'll find the imaginary solutions. But for now, we're going to say no real solutions, dust our hands off, and call it a day. So the quadratic formula looks wild, but it's actually a very foolproof method to solve quadratics. You know, doing it by hand is a little wild, but we have a calculator that's going to be able to help us to do this in a foolproof way. We don't have to get stuck factoring or graphing. We can just plug all of the numbers into the quadratic formula and find our solutions. It's what I like to call the foolproof method of solving quadratics. Let me know if you would like for me to sing the song for you again, and I gladly will. 10 bonus points for anybody who learns the tune and sings it to me in class. See y'all later.